Welcome back, Generals, to another Let's Fix Generals 0 Hour to make the best game ever. Yeah, okay, last session we did implement a new frame rate limit class towards trying to decouple the render frame time from the simulation frame time, which then unlocks certain fixes and mechanics and improvements that should be good across all things single player. So campaign, skirmish, replay, playback, all these things. It will be nice for these. Doesn't affect multiplayer, but all things single player. Yeah, so the frame rate limiter that we added seems to work. I'm still a bit wary about this frequency thingy here. Let me inquire once more with brother ChatGPT. Is the frequency returned by that always the same across the runtime of a program? Yes, guaranteed to remain constant for the lifetime of your program, and typically for the lifetime of the system's boot session. Okay. Okay. Okay, cool. Well, let's hope that this works on all machines. I remember I used this counter once for implementing it in Gen 2, a similar way. And then there were problems that on Windows 11, the timers were suddenly totally wrong and the frame rate would be capped incorrectly. And I still don't know what I did wrong. Maybe I did something wrong, but I couldn't figure it out because on my machine, on Windows 10, it was working just perfectly fine. There was nothing wrong. So I really wonder what was up with that. Yeah. Yeah, I don't know. Maybe I made some mistake in the calculation. It's certainly possible. Okay. Okay, maybe we can then also move this into a new file. I don't think this has to be in here in Game Engine. Yeah. Good. Good. So we have here this guy. Yeah. Oof. What's going on here with the indentation? What is this? Jesus Christ. Oof. Okay, maybe before we continue, there was one more thing that maybe we should look into before we continue here. So I think Ryan DeBoer is waiting here for a review on this guy. Let me see. So that is Unify. Unify Gen. Perhaps just do out builds. Init filters. Why are there two now? So our just has one. That's weird. Maybe because there's still some code that calls this. Maybe. What is this function? Flush. This formatting does not match 0 hour. If you copy paste code, disable the auto format feature in your IDE to preserve the original formats on copy paste. Otherwise, use WinMerge or similar to merge the code correctly with all formatting. So all identical formatting. Instead of making a copy of the whole file, you can move it. You can move it into core. You can move it from 0 hour to core. From generals MD to core. then use it in both games. Yeah, this looks suspicious here. I'm just selectively looking at certain things. He needs to make another pass here. Fix the formatting so the formatting matches. Then we probably need to take a look in WinMerge, how that looks. Set the texture class. Set the texture with desired height and width format. Okay, so currently this change has a lot of incorrect white space changes, which one, make it make the diff larger than necessary, and two, make the format different to 0 hour. When merging from one game to another, merging from 0 hour to generals, preserve the formatting of 0 hour. This will make reviewing and diffing easier. Okay. Okay, let's get back to our code. So game engine. Limit the frame rates. Good. So we have this. Okay. Yeah, we tested this last session and it worked all right. So I think what we can do here is spike us at bug fix bug fix. Re-implements. Set the dates. Yesterday was 05, 08, 2025. Re-implements the frame rates limiter to properly to more accurately cap the frame rates. To more accurately cap the frame rates to the desired limits. Mm-hmm. I can move that to a new line. Okay, so the white space here is all wacky. Maybe we fix that where we add it. Jesus Christ. Like so, I guess. Okay, so that is that. Let me enable fraps here one more time. Okay, then let's move this code here into a new file. Common game engine source common. Where should we put that? Game engine includes client logic. Where's game engine? Here. No, let's put it here then. Frame rates limiter. Frame rate limits, I don't know. Oh, that's the wrong folder. Core, game engine, include, common. Here, frame rate limit, and then we go to game engine, source, common. Frame rate limit CPP. Then we search for game engine. Game engine dot. Yeah, no. Here. Yeah. So we need to add a new file here, frame rates, frame. Yeah. Yeah. Includes common frame rates limit.h. Then we go to source common frame rates. Where's the F? Must be here, right? Good, then. So now we have files frame rates limits here. And we can take this guy and we copy it in here. Then we remove this and we remove that. And that's it. Then we go to frame rate limit CPP. Then here we do a pragma once. Here we do an include pre-RTS.h and include frame rates limit.h. In common. There we go. Then we move this here and this here and remove this and this. Okay. That looks good to me. Yeah. Then we also add the prologue here. There we go. That's here. It's like this. Okay, that means it's now out of the way. And then in game engine, we can include this guy here, common. Frame rate limits. Now we need to find where we put that code. Where is it? Here. Let me comment this out. And frame rate limits is still here. Let's see if that compiles. It does. Fantastic. Pretty basic for now, since many, many years, decades. Yeah. Okay, that looks good. I'm disabling this in Eternal. Who's I? Who is I? This is why I never use I in comments. He put a. This is probably his tag name. But yeah, I think it's not good to use I or we or us or like a person in a comment. It's better to just say, okay, this author, and then describe it in a neutral way, whatever was changed. So for example, here the description here would be this this sleep is disabled in internal because many people need alt-tab capability. Yeah, it can be written like this. Okay, so this compiles. That's great. Great. Okay, then I think we can now clean up the current stage. I would say we create a new branch and we call it work in progress, frame rate limits. Okay, so we have this guy. And this guy. Okay, here we can remove this. Then we can remove all this. Maybe we should clarify our comment a little bit here. Re-implements a frame rate limiter with higher resolution. Counters. Frame rate limiter with higher resolution counters to more accurately cap the frame rate to the desired limit. To cap the frame rate more accurately to the desired limits. we could also do is we could move this off the stack. So here it's on the stack always. Maybe it can be a member or rate limits. So either we move it out here or frame rate limits. Frame rate limits. Frame. So if we put it in here, then as a member, then that means we need to include the header here. Okay, so what we can do is class frame rate limits, frame rate limits, frame rate limits. Here we do frame rate limit equals new frame rate limits. How about we we add another function here, void init. see, start. Do start. Init is good. Maybe what we can also do is just leave it the way it was. And we just set it to null here. Why don't we just allocate it locally in here? We can do that. Don't need to have it a member. Then it's not on the stack, it's somewhere. We just have it here. Yeah. Put it here and then we delete it down here. There we go. That's it. There's no return. There's a try catch. Okay, then we can revert all the other things we just did there. So we can revert this and this. Okay. I think that's it. Okay, so this is a bug fix, FPS, fix inaccurate frame rates cap. Frame rate cap. Okay, so this is number one. Good. Then next change, we can now explore so we have use FPS limit. Why is this global data? Why do we have why do we have global data that controls the FPS limit and then this value here? Why don't we just have this one value that determines the outcome? So if max FPS was set to 0 or smaller than 0, then we don't cap, right? Okay, I really would like to get rid of this guy here, but it's probably also set with a command line. Yeah. Let's see. Frames per second limit. Well, I think that's a separate setting because they want to say, okay, we set an FPS limit and we still want to preserve a separate control to enable or disable this limit after we have set a value. I guess in that sense it makes sense, yeah. It's just too bad that one setting is here in global data and the other inside game engine. Yeah, so you have frames per second limit in here. There's another frame rate limit here. What the hell is that? What is this? Display draw. Oof. Oof. full screen render. Oh my gosh. Okay, let me put a breakpoint in here. Oh man. Oh. It's hit. Jesus Christ. What the hell? We have another function that limits the frame rate here. Oh, Jesus Christ. Jesus Christ. Why? Oh my gosh. Oh. Can we remove it maybe? What's this comment? Lorenzen and Wilczynski move this from its native position above for the purpose of letting the particle system look up the render object's transform matrix, while it is still valid, having done its client's transforms but not yet resetting to tautological transform. The result is that particle systems linked to bones and drawbles objects move with the client transforms now. Revolutionary. Okay. Fantastic. All caps. He's yelling in our face here. Unacceptable. Okay, I wonder if we really need this or if we can remove this. Oof. Let me remove this. Okay, so the frame rate is limited here. Now we go to skirmish. Now the frame rate should be limited at 60. Yeah. It is. It's load a video. 30 FPS. this cutscene has a frame rate limit of 20. I wonder why the cutscene has such a low limit. So it plays back slower. Yeah, it plays back slower effectively. Okay, but it seems like everything still works fine, so I think we can remove that, and we shouldn't have multiple frame rate limiters here. Let me see if there's more of this bullshit. Oh, there's so much here. Gosh. Okay, this one is just some debug. Okay, what do we have here? We have some execute action. Okay, we don't care. Game logic. Okay, this one is also disabled. What is this? Some debug, whatever. Okay, options menu, use FPS limit. Okay. Disable FPS limit. Get FPS limit enabled. Launch game. Staging room game info. Okay, so fine. We keep this as is for now. So we have here max FPS, maximum frames per second. So let's add a new setting and call that int, well, let's say unsigned int. We should also make this unsigned. Max FPS. Is there any reason that this needs to be integer? Int FPS. Frames per second limits. Okay. I'd say we leave it integer for now, yeah. Maybe. Let's see. let's make it integer. Okay, so we need max simulation frame time. By the way, there's one more thing that I wanted to do, and that is here, target frame time. Here I would like to name this sleep seconds, if it lets us rename it. Doesn't. Sleep seconds. Elapsed seconds. Target seconds. Okay, then let's get back to game engine. If it lets us here. Okay, so we added a max simulation game. Simulation FPS. This will be maximum render frames per second. And this will be maximum simulation frames per second. Now, simulation frames. So let's say I mean, realistically, we can only set it to 30, right? What happens if we set it to, I don't know, 60? And then max render FPS to 120. Oh. Yeah, it just means that if the simulation FPS is, let's say it's set to 60, then it just means that the game time runs twice as fast. Yeah. Because the tick rate will still be 30. Tick rate is fixed at 30. Yeah. Simulation FPS will be 60, so the game will run like 1 second will be two, so one runtime second will be 2 seconds simulation. Yeah. And the frame rate is independent. The render frame time is independent of that. Yeah. Okay. Then let me see where this guy is set. No, this guy. Default max FPS 45. Why is that 45? What is this? Why is the default FPS 45? What is this? Huh? Where else is this used? Why is it default max FPS 45? That's weird. I would say we take this guy and we move it away and we move it to game defines. I think that's a better place for this. Put it here at the bottom. And we say default. Why does it have to be 45? Max render FPS. Let's set that to 30 because this is what we usually start with into the menu, right? So let's put it to 30. And then we have a define default max simulation FPS. And we also put that as 30. Okay. Then we go here, max render FPS. I don't know why this is in the init function. How about we move it to how about we move it to the constructor? Oh, it starts with 0. That's where. Okay, so we have a simulation FPS and the regular FPS. Okay, so then next step, we go to this one update function. Where is it? Game engine resets. So yeah, this one. Good. So the game logic update. How will we call it? Logic FPS. Logic FPS. Logic. Yeah. Okay, logic FPS. I think that's a better name. Let me go back here. So we rename this to logic FPS. Okay, so that's logic. Then let's rename this to logic FPS. Okay, and then we go back to where we were before. Here. Good. And now we need to say we need to basically updates. Okay, it looks like we do actually need to put frame rate limits. Class frame rate limits. Okay, we should actually put it here. Frame rate limits. Say this is render limits, logic limits. How about that? that. Okay, render limit, logic limits. Okay, and then do we don't want to allocate them right here already. No, we put them to null. Instead we allocate that in new frame rate limits. So we put here the logic limits. So where's the update function called? Is it in here? Update here. Then I would say we allocate it in here. Logic limits and render limits. Down here we do this and logic limits. Then this is render limits, weights. And here we do so we don't want to wait, we want to skip. But it's a problem, right? I could imagine that if the frame rate, if the render frame rate is just barely above 30 and these things are separated, then it could cause stuttering. Maybe. Okay, so a frame rate limit, basically we need another function here. So we have max FPS and we need to have void test. Bool test, wait and test. Wait, wait for the frame frame rate cap. Wait to hit the frame rate cap. Check if the frame rate cap was hit. Okay, we need a new function here. Bool. Bool. So essentially we need to, by the way, why do we call it end? Doesn't matter. Good. So here what we can say is this. Then we have target seconds as well. And then we say return elapsed seconds smaller / larger equal target seconds. How about we rename this to current? What is the parameter type name? Count. Maybe just call it tick. Tick is a good name. Okay, so basically we have a function where we can test if we have already reached the elapsed seconds. Okay, now we can make this const. Okay, I'm a bit wary about how this will actually play out. I expect that there can be stuttering. If the frame rate is just, if it's not larger, if it's not much larger than the logic time. So I'm a bit suspicious about this, but let's see. So we say logic limit tests. Test is maybe a bad function name, isn't it? Logic limit. Maybe a better name would be passed, limit passed, pass, it's passed. Okay, for some reason it doesn't. Well, it passed. We need to pass a frame rates, logic, max logic FPS. Okay. Right, so we renamed it to past. There we go. How about we make this, and this is a bit long, this condition. How about we do a, I would say we refactor this to the following. We say if the network is null, then we do that. Else, say a single player menu replay multiplayer. It should be one word, single player, multiplayer. Oof. Maybe not. The spelling check is not happy with that. Okay. And then we say here if not is paused and is passed. If not is paused and is passed, then it does the update here. And in multiplayer, it checks if the frame is ready, right? If frame is ready, updates. Then we comment this here out. I don't think we need this comment here. Okay, let's see how that works. So right now, what will we expect? So the simulation time is now 30, and the frame rate starts at 30 as well. Okay, fair enough. Now, if their values are the same, it should probably work just fine, because we wait this kind of amount. Yeah, so I think if the frame rates of both of the rendering and the simulation are exactly the same, then the update should be very smooth. Like every render frame should have one logic frame, because essentially the render frame that will wait towards the 30 FPS, right? And then once that is done, then this is guaranteed to pass the next time we reach here, right? It has to, because the render time has passed as well, right? It has waited a sufficient amount of time, and now we go to the next frame, and so this should pass, right? Or am I missing something? Let me think about this. Only, let me see where this is called, updates. Oof. Update is here. Okay, the problem I see is that this happens afterwards. Not sure. Let's just test it. Let's see what happens. If it's smooth or not, or if there's some stutter. Yeah. I'm a bit suspicious about this. I need to think about this more. There could be some problematic edge case. Okay, let's load into the mission. Okay, so we have 60 FPS render time. And the simulation time also looks speed up. Okay, that's not working as I expected. Why not? Let me put a breakpoint here. Logic limit. Logic FPS is 30. Yeah, this is certainly not the normal game speeds. um, I can see a bit of stutter, I think. Okay, so but we have a fundamental bug here. It doesn't work as advertised. Why not? Why is this? It should skip. It should skip and pass. Skip and pass. Skip and pass. Did we make an error in the implementation? We have tick frequency. How about we add an else here? We just put something in here. Let's put a printf so we can put a breakpoint. Okay, it's never hit, so it never skips. Okay. Well, that's not good. Okay, that's unexpected. Huh. Okay. Because we never reset this, that's why. Oh boy. I see why. We have to put mstart to tick. That's why. Yeah. There we go. There we go. Oh boy. Now we have the opposite problem. It's not advancing at all. It is advancing. Never mind, it is advancing. It just took a real long... Oh shit, it's slower. Okay, it's very slow. Uh-huh. Why is it so slow? Okay, that's unexpected as well. Why is that? Tick, start, tick, start. Ah. Right, I know why. Because if we only... Right. If elapsed seconds is larger this target seconds, then we do this and return true. Otherwise return false. There we go. Oof. Is it normal to be that slow? It feels kind of slow, doesn't it? The camera is smooth. It feels a bit stuttery, the way the thing moves. Oof. Oof. It would be good to know. So the game speed is certainly, it looks like it's about correct, right? So everything moves slow. So okay, so what I would like to know now is how many let me add a int counter. Int counter 0 and array. Let's put like 10. 10, and we initialize it with 0. Yeah. And then let's do a debug counter. Okay, so the debug counter, we set it to 0 here. Yeah. And we set it to ++ here. Yeah. And then here we do debug array, debug counter, ++. Okay, let's start debugging. So ideally, we expect now that most of the values being written into this debug array will be at index 1, right? So we have one frame where we don't update the logic, and then another frame where we update the logic. And they should always alternate, because the render frame time is 60 FPS, and the logic update is half of that. So it should, every second frame, it should update. Every second render frame, it should update the logic, right? But if like there's a very small discrepancy in the timing, where it maybe takes two render frames to update the logic, then that's too much, right? We don't want to go into that situation, because then we slow down, we artificially slow down the logic. That wouldn't be good. If it maybe happens once in a blue moon, it's not a big deal. But if it happens regularly, then that is not good. Yeah. Let's see. Let's move a bit around here. Let's build some things. Yeah, build some doses here. So the camera feels fine. We can scroll around. Mouse is good. So overall, it works, right? That's the good news. It works, but I'm a bit worried that there is some tiny issue. And if there is, if we can prove that, then we need to look into how we can solve that. Okay, let's build here some soldiers. Let's take the dozer, drive around a little bit. Yeah. Okay, I think that's enough. Then I will click here, and I click in here. Good. And now we take a look at the array. Aha. Yeah. That's the problem. Yeah. So as you can see, sometimes, or very often actually, so if they were all at one, that would be great. Sometimes they are faster. I think that's fine. That's if, I guess that happens if the render frame time is low. So if there's like a stall or something, then this happens. This is fine, but this is not fine. That means we have to wait 2 render frames before the logic updates. It's too long. Yeah. This number needs to be 0. Yeah. How do we do that? That's a problem. We could add some epsilon. Yeah, we could add an epsilon to the target frame rate here. That would be possible. Yeah. Epsilon. Okay, let's do the following test. Before we tackle this, let's restart the game. Let's first investigate the scenario where we have 30 FPS. Yeah, let's try to figure that out first. So if we have 30 FPS, then ideally all would be in ray 0. If the render frame time is 30 FPS and the logic frame time 30 FPS as well, then all updates here should be in array position 0, right? So let's test that first. We go to Skirmish and we set the frame rate to 30. There we go. Okay, then we press play and then I can already see it's slower than it should be. So this already doesn't work correctly. Okay. Okay, then let me put a breakpoint to confirm. Array, yeah. Okay, this doesn't work already correctly. Yeah. So all the frames should be in 0. There's no excuse. There should be nothing in index 1. Yeah. Okay. That means there is a notable discrepancy. Yeah. And given that it's like 50-50 split, it's probably it alternates and like there's the small discrepancy where sometimes it's a bit faster, sometimes it's a bit slower, and so it's a hit and miss, right? And we need to change the update or the frame limit in a way that this doesn't happen. Okay, so my suspicion was that maybe the position of this guy is not appropriate. Let me think about this. Or okay, that's a little problem. But it must be solvable. I'm pretty sure that this can be solved. Okay, so we take the frame time. It's updated. Then what? Aha. Yeah. Okay, I need to wrap my head around this shit. So the problem is that the timers are not properly aligned. Like this timer is independent of the other one, and now this one. After this wait is done, this guy is updated, the time in here. But for the update, this one happened before here in there, right? So that one is updated, and then it goes down here. It will eventually wait a bit. Yeah. How do we solve that? We could have an epsilon that could alleviate some pain, but it sounds kind of random. So epsilon, yeah. I think that would be a quick fix. Just reduce a bit the threshold. Yeah, but that doesn't sound like a solid solution. We still need to fix it properly. Oof. It's a bit of a problem. I suspect that if the frame rate is super high, then this is working perfectly fine. Yeah. Update. What if we move the render limit above? That doesn't solve anything, I think. No. Could say maybe we should work. What we can experiment with is maybe we return a float here, aka a real. And so and we do here return real elapsed seconds. And then we go to then here we go to add a real frame time. Frame time. Put that to 0.003. So 1.0f divided by max render default max render FPS. And then the update, here we pass our frame time. Then in this update function, we update frame time, real frame time. And then we say here, instead of this, we do real logic frame time. Logic frame time, we put that to 0.0f. Yeah, logic frame time. So we say if, well, we do here logic frame time plus equal frame time. Then we say if not is paused, if logic frame time is larger than 1.0f divided by this, here we deduct this time. So we have like a little bit of a budget, so to say. Let's do a const real target frame time. Larger equal. This could work. Let me remove this here. Yeah, maybe this helps. I'm not sure. I'm not sure. Yeah, so basically now we don't have a separate counter for, well, we still have a counter here, but it works now differently. Well, it doesn't even compile. Why not? What? It's a virtual overload. I see. Real frame time. There we go. Okay, so basically, let's go back to game engine. So we count up, we add the frame time on top. It still doesn't compile. Jesus Christ. Huh? What is the problem? Why is it saying it's an abstract class? What is this? Updates. Is paused. Logic limit passed. Is paused. Why is it frame time? Everything seems to be fine. What is the problem? Hold on. Is this a different update function? No, it's not. What are we doing here? Hold on. Okay, so this will call Win32 game engine updates. And that will call back into game engine updates, which is here. So it looks like it works, should work. I don't understand. pure virtual function. Update has no overrider. Aha, hold on. There's... Oh... We cannot change update because that is subsystem interface. Oh boy. Oh, I see. I see. Okay, well then we need to do it differently. Oh, that's a shame. Real frame time. Let's call this updates frame time. Need to go to the constructor. Then here we need to do that, frame time, wait, max FPS. And then here we need to go here, frame time, remove this again. Okay, and then we need to go back to this guy and revert the changes here and here as well. Okay, let's try that. Fails, okay. What is wrong? Okay. How about we just call it in frame time? Okay, that works. Let's see how that looks. No. So it's 30 FPS. Okay, it already looks better, I think. Yeah. It looks better to the eye. Yeah. Now we need to add some debug to verify, but it already looks better to me. It looks smooth. Yeah. It looks pretty smooth. Okay, that is very, very promising. Let's add some debug. We can do the same debug that we added to the frame rate limit down here. We add these guys here. Game engine. Let's add them up here. And then... Plus, plus. There we go. Else plus plus. Okay, let's try that. But this looks very, very promising. I like the smoothness of it. Oh, we have we have some duplicate symbols. Fair enough. Let's comment this out. Okay, let's put a breakpoint and see how it looks. Oh, perfect. 100% is now in the first bucket. Okay, that is pretty amazing. That is really, really good. That is fantastic. That is absolutely fantastic. Okay, let's test this with 60 FPS as well. Okay, with the 60 FPS, we expect that most will be in the second bucket, index 1, and maybe some in the first. Yeah, but none in the third. Yeah. Oof. Okay, that doesn't work correctly. Actually, it does work now. How? It had a weird start. What is this? Huh? It looks fine right now, but at the start it looked like the doser worked way too fast, no? Okay, well, it looks pretty solid right now. Okay, let's see the results. Let me click in here. Okay, what do we have? Oof. Yeah, there are a bunch of frames at 0. Many frames. Okay, the good thing is we don't have any here in this third bucket, so that's good. This is 0. Fantastic. But there are way too many here. I would have expected a few. Like if we have some stalls here and there, then there could be like a small number here. But 708, that is way too much. Why is that happening? Okay, let me restart that match. Yeah, look, the dozer is so fast. Huh? Why is this happening? Now he's slow. Okay, I'm confused by this. Okay, quite frankly, I don't understand why this happens, but I think we will figure it out. Yeah, probably some stupid mistake, but that is I didn't expect that. Yeah, that kind of issue is totally not on my radar. I would have expected that alternating some frames and things like this, but that it somehow is super fast at the start of the game until you move the camera a bit around. That's weird. That is weird. I don't understand what is this. But okay, I will take a break here. Next session we investigate. Try to polish this more and fix it up, and maybe we can get it to properly work. No, maybe not. We'll see. Good. Then I wish you a great day or night. Until next time. Goodbye.